Welcome to section 08. Today we're going to talk about the Pythagorean theorem. Just a couple of vocab terms today. We got the Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse C is equal to the sum of the squares of the lengths of the legs A and B. So it'll look something like this: A squared plus B squared equals C squared, where C is the hypotenuse of the triangle and A and B are the two leg lengths. We also have the converse of the Pythagorean theorem. Okay, so that's kind of like the opposite. So if the sides of a right triangle have lengths A, B, and C C squared is equal to A squared plus B squared, then the triangle is a right triangle. So the Pythagorean theorem and its converse are opposites of each other. The Pythagorean theorem, we start with a right triangle. If we have a right triangle, then we know that we can use A squared plus B squared equals C squared. In the converse to the Pythagorean theorem, we know that A squared plus B squared equals C squared, so that we know we have a right triangle. First thing we're going to do is we're going to find the missing hypotenuse lengths. Okay, so the hypotenuse is always the side that's across from the 90-degree angle. So here and here. So when we're finding that, we know that it's a right triangle because of this symbol right there. That means it's a right triangle. So if we're given the two legs and we're asked to find the hypotenuse, we can take A squared plus B squared equals C squared. So we're going to have 5 squared plus 12 squared equals C squared. 5 squared is 25, 12 squared is 144. Add those two together, we get 169. Okay, so now we've got 169 is equal to C squared, but we want just C. So to get that, we would need to take the square root of C squared, and the square root of 169 would give us that our C, or hypotenuse length, is 13. So go ahead and give that a try on the second one. We've got side lengths of 6 and 10. Go ahead and pause the video, find C, and then hit play and see how you did. Okay, so as you can see here, we've got our two legs of 6 and 10, so I should have 6 squared plus 10 squared equals C squared. 6 squared is 36, 10 squared is 100. Add those together to get 136 is equal to C squared. Square root both sides, and C is about 11.7. So we had to round because we didn't get a good answer like we did on the first one. We can still use the Pythagorean theorem when we're looking for one of the leg measures. Okay, we're going to use the same setup, A squared plus B squared equals C squared, but now instead of not knowing what C squared is, we're not going to know what A squared is. So we got A squared plus 7 squared equals 25 squared in this example. So I still don't know what A squared is. 7 squared is 49. 25 squared is 625. I subtract the 49 over to the other side. So I get that A squared is 576. Now to get rid of the squared, I square root both sides. And the square root of 576 is 24. So my side length here is 24. Do the same thing on the second one. Pause the video, find a measure for A, and then hit play and see how you did. Okay, so as you can see, I've got A squared plus 2 squared equals 4 squared. 2 squared is 4, 4 squared is 16, so I've got A squared plus 4 equals 16. Subtract the 4 over to the other side, A squared is equal to 12. Square root both sides, and I have that A is about 3.5. Okay, now the one thing you need to know about this is that I chose to leave it as A squared. Okay, I would get the same exact thing if I decided to do it as 2 squared plus A squared equals 4 squared. Okay, so the order of that doesn't really matter. The legs can be in any order that you want them to. The only thing is you have to make sure the hypotenuse is on a side by itself. Now we're going to use the converse of the Pythagorean theorem. Okay, so now we're given the lengths of a triangle. So if I draw a triangle here, and I know the lengths are 5, 7, and 9. Now generally, the biggest side is our hypotenuse. Okay, so the 9 is going to go as the hypotenuse. So we'll go at 5 is A, 7 is B, and 9 is C. My job is to figure out whether or not the triangle is a right triangle. So I'm going to use this formula here that we've been using, and if it is in fact equal on both sides, then I know I would have a right triangle. So I'll have 5 squared plus 7 squared, and I'm going to see if that's equal to 9 squared. 5 squared is 25, 7 squared is 49, 9 squared is 81. If I add these two together, I get 74 is equal to 81, and that is not equal. So therefore, it is not a right triangle. Okay, so you have to be equal on both sides in order for it to be a right triangle. This doesn't happen, so this is not a right triangle. Okay, so now the next one, is this a right triangle? So I've got sides of 5, 12, and 13. I want you to pause the video, use the Pythagorean theorem to see if it's the same on both sides, and then answer the question, is it a right triangle or not? So pause the video, show all your work, and then hit play and see how you did. Okay, so I've got my 5 squared plus 12 squared equals 13 squared. 5 squared is 25, 12 squared is 144, 13 squared is 169. I add 25 and 144 together and I get 169. 169 is in fact equal to 169, so yes, it is a right triangle. Okay. Those of you that are more observant will know that this example we used already earlier in this lesson, but it still helps to prove a point.